From the chirping of birds at dawn to the comforting voice of a loved one, sound enriches our lives in countless ways. Hearing is a gift that allows us to connect with the world around us. It's a complex and fascinating process that takes place in the intricate machinery of our ears and brains. Let's embark on a journey to explore the remarkable way in which we hear. Our ears are the gateway to the world of sound. They capture sound waves and transform them into electrical signals that our brains can understand. This incredible journey begins with the outer ear, the part we see. The outer ear consists of the pinna and the ear canal. The pinna is the visible, oddly shaped part of the ear that we adorn with earrings. Its unique curves and folds serve a crucial purpose. They act like a funnel, collecting sound waves from the environment and channeling them into the ear canal. Imagine you're holding a large bowl to catch raindrops. The pinna works similarly, gathering sound waves like the bowl collects raindrops. The ear canal, a short, narrow tunnel, then guides these captured sound waves deeper into the ear. The ear canal plays a vital role in protecting the delicate structures within the ear. It's lined with tiny hairs and glands that produce earwax, which helps prevent dust, dirt and insects from reaching the sensitive eardrum. At the end of the ear canal lies the eardrum, a thin cone-shaped membrane. This delicate structure marks the boundary between the outer ear and the middle ear. When sound waves traveling through the ear canal reach the eardrum, they cause it to vibrate. The eardrum is incredibly sensitive. It can detect even the faintest sounds, like the rustling of leaves, and respond to a wide range of frequencies. These vibrations are the first step in transforming sound waves into a form our brains can interpret. Beyond the eardrum lies the middle ear, a small air-filled chamber. This chamber houses three tiny bones known as the ossicles, the malleus, incus, and stapes. These bones are the smallest in the human body, and they play a crucial role in amplifying sound. When the eardrum vibrates, it sets the malleus, or hammer, in motion. The malleus in turn strikes the incus, or anvil, which then moves the stapes, or stirrup. This chain reaction amplifies the vibrations from the eardrum, much like a series of levers. The stapes, the last bone in the chain, is connected to the oval window, a membrane-covered opening that leads to the inner ear. Section 5, the inner ear, a world of vibrations. The inner ear is the most complex part of the auditory system. It's here that the mechanical vibrations of sound are transformed into electrical signals that the brain can understand. The inner ear is a labyrinthine structure filled with fluid and contains two main sensory organs, the cochlea for hearing and the vestibular system for balance. Our focus is on the cochlea, a spiral-shaped, fluid-filled structure that resembles a snail shell. Inside the cochlea lies the organ of Corti, the true organ of hearing. The organ of Corti runs along the length of the cochlea and contains thousands of tiny hair cells, the sensory receptors for sound. Section 6. Hair cells, transducers of sound. Hair cells are the true heroes of hearing. These remarkable cells are named for the hair-like projections called stereocilia that extend from their tops. When the stapes vibrates the oval window, it creates pressure waves in the fluid inside the cochlea. These waves cause the basilar membrane, a flexible structure within the cochlea, to move up and down. This movement bends the stereocilia on the hair cells. The bending of the stereocilia triggers a series of mechanical and chemical processes within the hair cells, ultimately generating electrical signals. Section 7. The auditory nerve, a highway of signals. The electrical signals generated by the hair cells are transmitted to the brain via the auditory nerve, a bundle of nerve fibers. Each hair cell is connected to several nerve fibers, and each fiber responds to a specific frequency of sound. The auditory nerve acts like a highway, carrying information about the pitch, loudness, and timing of sounds to the brain. This information travels at lightning speed, allowing us to perceive and respond to sounds in real time. Section 8. The brain orchestrating the symphony of sound. The auditory nerve transmits its signals to the auditory cortex, the part of the brain responsible for processing sound. Here, the brain performs an incredible feat of interpretation. It decodes the complex patterns of electrical signals. from the auditory nerve, distinguishing between different sounds based on their frequency, intensity, and timing. The brain can identify a vast repertoire of sounds, from the whisper of wind to the roar of a jet engine. It can also localize sounds in space, determining the direction from which a sound is coming. Section 9. The miracle of hearing. Hearing is a miracle of biological engineering. It's a testament to the intricate design of our ears and the remarkable processing power of our brains. From the moment sound waves enter our ears to the instant our brains perceive them, a complex chain of events unfolds with astonishing speed and precision. Hearing connects us to the world around us, enriching our lives with music, language, and the sounds of nature. It's a gift to be cherished and protected.